Alright, so in this video we go over section 7.6, the double angle formula and the half angle formula. So this section is going to be a bit similar to that we did in the previous one, 7.5, in which we found values of trigonometric functions of sum and difference formula. But in this case we're going to look at new formulas. Well, in this case here they are. Sine to theta, so that's a double angle, and then the equivalents in terms of sines of simple angles. I mean just theta, not twice theta or so. And then for cosine to theta we have 1, 2, and 3 different ones, and then we have one for tangent to theta, for which is the double angle. So let's start by looking at one example, and then in this case, well, if sine theta equals 3 pi over 4, where theta lies between pi over 2 and pi. By the way, this means second quadrant, right? Quadrant. All right, second quadrant, that's pi over 2 to pi, right? It's this region right here. Find the exact value of sine to theta and cosine to theta. Well, first of all, what are they giving us? Well, they are giving us sine theta equals 3/5. But keep in mind that sine is y over r. So the y coordinate is of the related point in the circle is a 3. The x we don't know, and the radius r equals to 5. So we're going to use Pythagorean theorem to find the x coordinate, as we have done these last couple of sections. So in this case, r squared, which is 5 squared, equals x squared to be determined, plus y squared, which is 3 squared. 25 equals x squared plus 9. Subtract 9 from both sides. X squared equals 16, and actually no more square, plus or minus the square root of 16, which is plus or minus 4. But in this case, which one do you think are we going to take? In this case, we're going to take the negative one, because look at the displacement in the x-axis. It goes in the negative direction, so that's a negative 4. All right, so let's see. Also keep in mind that cosine theta, which is x over r, because we're going to need it eventually in this exercise, that's going to be the x coordinate, negative 4 over 5. All right, so sine to theta. Okay, first of all, let's write down the formula. Sine to theta equals 2 sine theta cosine theta. But in this case, what is sine theta? Sine theta is given, that's 3/5. And cosine theta, we wrote it down here, negative 4/5. So in this case, 2 times 3, which is 6, 6 times 4, which is 24, and divided by 5 times 5, which equals to 25. Don't forget the negative sign. Final answer. That's the value of sine to theta, given sine theta equals 3 over 5 in the second quadrant. All right, so let's look at the next one. Well, cosine to theta, and in this case, cosine to theta, keep in mind that we have 1, 2, 3 different formulas to choose from. Well, actually the book, because I pulled out this example from the book uses cosine to theta equals 1 minus sine squared theta. I'm going to use another one. I'm going to use the first one instead. We should get the same. Actually, let me show you on the book how they use cosine to theta. 1 minus 2 sine squared theta, we should get 7 over 25. All right, so let me do it. Cosine squared theta e minus sine squared theta, where cosine is -4/3, no, -4/5. Quantity squared minus sine squared, which is given 3/5 squared. Alright, so let's see. 4 squared, which is 16. 5 squared, which is 25. Minus 3 squared, which is 9/25. And what's 16 minus 9? 7/25. Just the same way as it is in the book. Develop a formula for tangent to theta in terms of tangent theta. Well, actually, it's right here, but what we're going to do is prove this formula. How are we going to do this? Well, so in this case, I'm going to write, well, first of all, recall. You might want to recall that tangent of alpha plus beta equals tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. Recall that that's the formula for it. So what I'm going to do is write this tangent of 2 theta as tangent of theta plus theta, right? Because theta plus theta equals 2 theta. And then I'm going to use, this is our alpha, this is our beta, and I'm just going to use this formula. So tangent of theta plus tangent theta over 1 minus tangent theta tangent theta. In this case, alpha and beta are the same, theta and theta. And well, these are two like terms, so this is only 2 tangent theta over 1 minus tangent squared theta, as it has to be shown. Well, if we look at the formula, it's right here. It is the same. All right, let's move on to the next page and see what about exercise. Okay, develop a formula for sine 3 theta. Well, in this case, this section is not about really triple angle. It's double angle and half angles, but we can use the same type of thinking, you know, to develop a formula for sine 3 theta, or even 5 theta or 7 theta. Well, I mean, the process, the larger the coefficient of theta gets, well, the process gets a little bit longer. Well, so I'm going to use the same type of thinking as I did in the what was that, in the tangent formula. But in this case, first of all, what you might want to recall is from the previous section. Recall that sine of alpha plus beta equals sine alpha cosine beta, and then in this case plus cosine alpha sine beta. You might want to recall that formula. It's going to come in handy here when it comes to this example. So I'm going to write sine 3 theta, in this case as sine of 2 theta plus theta. Don't be sure to put parentheses around this one because it's a sum of angles, all right? And well, in this case, you can think of this as the alpha and this as the beta. All right, so sine alpha cosine beta. So sine of alpha, which in this case is 2 theta, cosine beta, which is theta only, not 2 theta, plus cosine of alpha, which is 2 theta, sine beta, which is just theta. All right. Well, we are essentially done with using this formula right here, but we need to write this sine 2 theta and cosine theta in terms of both sine theta and cosine theta. We don't want these two thetas right here. So what we're going to do is we are going to replace this sine 2 theta, this one right here. I'm going to replace it with 2 sine theta. I'm going to use just a different color just so you can see what am I doing here. And then cosine theta plus cosine 2 theta. I'm going to use a different color. Cosine 2 theta, that's, well, you have different options if you recall from the previous page, but I'm going to use the one that says cosine squared theta minus sine squared theta. And then that times sine theta. Alright, this formula in pink is for sine 2 theta, and this formula in green for cosine 2 theta, which is what we learned in the previous page, the beginning of the first page. Alright, so let's simplify this a little bit. Well, 2 sine theta cosine times itself is cosine squared theta plus cosine squared times sine theta, that's a sine theta cosine squared theta, and then minus sine squared times a sine, that's a sine cubed theta. All right. Let's see. Do we have any like terms? And if you look at this, well, we have like terms. These two are like terms. 2a plus 1a. Well, that's a 3a. Well, in this case, sine theta cosine squared theta minus sine cubed theta. And that's a formula for sine 3 theta in terms of just sine theta and cosine theta without multiple angles. Alright, so let's see, what about what's now power reducing formulas? Well, what about this? So for example, sometimes we are going to have let's see, actually this right here was supposed to be 2 theta. This one that I'm going to erase. Well, your PDF will be updated to theta. Okay, silly typo on my end. Your PDF will be updated. All right, so sometimes we don't want powers. We want to go back to power 1 of cosine, but that implies going from single angle to double angle. So let's see. Let's write an equivalent expression for sine to the fourth. A sine to the fourth that does not involve any powers of sine or cosine greater than 1. Well, so that's what we want. We have a power 2 turns into 1. But in this case, we have sine to the fourth power. So sine to the fourth power of theta. What you might want to do in this case, well, keep in mind that this is the same as saying sine squared theta, the whole thing squared. Alright, sine squared is the same as 1 minus cosine 2 theta over 2. So I'm going to replace this one right here with all this expression right there. So that's 1 minus cosine 2 theta over 2 squared. And then what am I going to do here? Well, so this square is going to affect both the numerator and the denominator. So let me do 1 minus cosine 2 theta. Cosine 2 theta squared over 2 squared, which is 4. And then I'm going to use the formula for the square binomial. And if you want to recall that formula, minus b, quantity squared. This is simply a squared minus 2ab plus b squared. So I'm going to square 1. That's going to be 1. And then minus 2 times the quantity A, the quantity B, plus the quantity B squared, which is cosine squared to theta. Alright? And then the whole thing over 4. Alright. So in this case, well, it would be a really good idea to actually distribute this, well, split this fraction. That's going to be 1/4 minus 2/4, which is 1/2 cosine to theta, and then plus 1, okay, this is an invisible 1/4 cosine squared to theta. All right, let me move it here. You can see the whole thing. All right, now I'm worried about this one right here. Actually, well, let me write it in a slightly different way. I'm going to raise the power here, and then I'm going to write it down here. All right. So let me take a slight detour. So every time we reduce the power, that we use the formula. Every time we reduce the formula, we duplicate the angle. So for example, the single angle formula right here became double angle. The double angle right here will get duplicated into 4 times the angle. That means that if I had a 3, for example, that'll become a 6. Or if I have an 8, that'll become a 16, right? But in this case, this 2 theta right here, this one, will become duplicated this time. And be careful because we have a cosine, not a sine. So we're going to use this formula right here. So let me replace that with that. All right. So, well, the rest of the remaining is going to be the same. All right. The rest is going to be the same. So this will be 1/4. Well, actually includes the 2 right here. Includes the 2. Okay, so 1/4 minus 1/2 cosine to theta plus 1/4, and then in this case that's going to be 1 plus cosine. The 2 theta duplicates to become 4 theta. Divide that by 2, and then I think that's about it. Yes, we don't square anymore because this square goes with that one squared. Well, actually, maybe I shouldn't have written it down. Sorry about that. It still remains there. All right. So now let's distribute this 1/4 over, or actually just multiply this by 4 times 2. That's going to be, well, 1/4 minus 1/2 cosine to theta plus 1 plus cosine 4 theta over 4 times 2, which is 8. And then I'm going to split this 1/8 and cosine of 4 theta over 8 in the following way. 1/4 minus 1/2 cosine to theta plus 1/8 plus 1/8 cosine for theta. And we're almost done with this one, except for that we need to combine the 1/8 with the 1/4. I'm going to multiply numerator and denominator by 2 to have the same denominator, to have an LCD essentially. So 2 over 8 plus 1 over 8, that's going to become 3 over 8 minus 1/2 cosine to theta plus 1/8 cosine for theta. Final answer. That's the answer for this one. All right. Let's move on now. Let's look at the half angle formula. So in this case, we're going to work in a similar way to evaluate, to evaluate expressions involving these half angle formulas. All right. So well, as opposed to this, let me see, the other formulas. Notice the plus minus symbol. This plus minus symbol, by the way, it's going to be taken in account depending on the quadrant that we are working. All right, so let's look at a couple of examples. Let's look at a couple of examples in the next page, just so you can see what we're talking about. Well, so cosine cosine of, let's use the half angle formula to find the exact value of cosine 15 degrees. Well, this is the same as saying cosine of 1/2 of 30 degrees. All right, so having this written in that format is going to help us see and the relation with the given formula. So cosine, well, this is supposed to be, there's another typo here. Your PDF will come actually will come fixed. This is cosine, not sine. So we're going to use this formula, and then in this case, look at the plus minus symbol. Well, in this case, we are going to use the positive because 15 degrees, it's a positive angle. You know, it's a 15 degrees is in a quadrant rather, in which cosine is positive. All right, so let's see. In this case, alpha, in this case, alpha equals 30 degrees. So we're going to use the formula, well, the square root, big square root of 1 plus cosine of 30 degrees, but it changed color, over 2. So cosine of 30 degrees, well, using the unit circle, you might remember that's going to be square root of 3 over 2. Yes, these ones are going to get a little bit crazy. So that's going to be 1 plus the square root of 3 over 2 divided by 2. All right, in the beginning, yes, this looked a little bit crazy, but trust me, there's a way to go about these ones. Keep in mind, number one, that this one is the same as 1 over 1. All right, and in this case, what we want in this case is to simplify the complex fractions. There's a couple of ways we can do that. Well, using a global LCD, which is multiplying numerator by 2, dividing by, and the denominator by 2, or simplifying the numerator first and then dividing that by 2, or multiplying by the reciprocal of 2, which in this case is a 1/2. Okay, so in this case, I think I'm gonna go the second way. I believe it might be a little bit less confusing. Well, multiply by 2, divide by 2 to have the same denominator. So we are gonna have, in this case, the square root of 2 plus the square root of 3 over 2. And then that over 2. Be careful with this. Actually, let me put parentheses around, because essentially what we're going to have is a 1/2. I'm going to rewrite this. The square root of 1/2 times 2 plus root of 3 over 2. Yes, I mean, I'm not really doing anything interesting other than rewriting to make this look a little bit nicer. Well, so 2 times 2, that's going to be 4, and 2 plus root of 3. And well, in this case, using properties of radical, the radical of a quotient is the quotient of 2 radicals, and well, the numerator remains square root of 2 plus square root of 3 inside. But in this case, in the denominator, the square root of 4 is 2. It's an exact number, and that's our final answer. All right, sine of negative pi over 8. Well, in this case, notice we have a negative angle. Negative pi over 8 is it's located in a quadrant where sine is a negative value. Alternatively, what you might want to do, use the even odd properties. I would take advantage of those properties. I mean, so just so we can use them, you know, just so they are not there in our formula sheet or in our notes. All right, so I'm gonna write this as negative sine of pi over 8. All right, as the first instance. All right, well, what do we do next? Now we need to play with the numbers here. Actually, using the even odd properties explains why this time we are going to take the negative version, you know. So now I'm going to rewrite negative sine of pi over 8 as negative sine of, well, the trick here is to write this down as 1/2 times pi over 4, all right? Pi over 8 is the same as 1/2 of pi over 4. And in this case, our alpha will be pi over 4. So we're ready to use the formula. In this case, the first formula, all right? First formula, which in this case is, okay, minus. Don't forget to minus this time. And, well, that's 1 minus cosine of alpha, which in this case is pi. Well, actually, should have used pink instead. Pi over 4, and then divide the whole thing by 2. All right. But what is cosine of pi over 2 according to the unit circle? Well, 1 minus the square root of 2 over 2 divided by 2. All right, so I'm going to take a similar approach. Think of this as 1 over 1, the LCD multiplied by the LCD, which in this case is 2, to have the same denominator. And at the same time, I'm going to have these 2 multiply in the front. In the previous example, I showed you step by step, but I think in this example, we're good to just go the square root of 1/2 times 2/2, or rather 2 minus the square root of 2 over 2. And same approach, using the same approach, that's a 4. And, well, so then we use the properties of radicals. And the radical of a quotient is the quotient of the radicals. The square root of this humongous number remains the same. But in this case, for the denominator, the square root of 4 is 2. All right. Final answer. Final answer. All right, let's use half angle formulas for another type of problem like the ones in the first page. Well, I think we're going to need the formulas. Let me put it on the side. So we're given that cosine of alpha is negative 3/5, where alpha goes between pi and 3 pi over 2. That means, fancy way to say, third quadrant. All right? Third quadrant. So that means we are given a point that cosine of alpha is, in this case, negative 3/5, which means that they're telling us that x over r. Well, in this case, look at the position. The third angle, x is negative. Keep in mind that the radius is never ever a negative number, so it is going to be a point in which Negative 3 is x. We need to find y, and r equals to 5. And I believe it's going to be the same one as we did in the first page. Nevertheless, let me show you how to obtain the y coordinate. X squared plus y squared equals r squared. 5 squared equals negative 3 squared plus y squared. 25 equals 9 plus y squared, and y squared equals 16. And then using the square root property here, y equals plus or minus the square root of 16, which is y equals plus or minus 4. Again, in this case, the plus or minus is meaningful. Well, in the other example, notice we got this positive for y because of the quadrant that we were at. And in this case, well, it's going to be really meaningful because look at the position in the 4 quadrant. In this case, in the 4 quadrant, y equals negative. I mean, the third quadrant, y is negative. So sine alpha over 2. What is sine alpha over 2? Well, in this case, sine alpha over 2 using the formula. Okay, what is the sine? What is the sine of sine in this case? Well, in this case, okay, let's write this down as so that's the square root of 1 minus cosine of alpha. Okay. But actually we need to be very careful. Do you see why we need to be very careful here? Yes, that is true. We need to take the negative version. Keep in mind that we have for these formulas plus minus, plus minus, plus minus, and that's going to depend on the sign in which the trigonometric function, the sign that the trigonometric function takes in the corresponding what's this called, the corresponding quadrant. All right, so let's see. But the thing, well, actually in this case, never mind, we cannot just say that yet, because first what is the we need to take this inequality. Well, pi less than or equal alpha less than or equal 3 pi over 2. Okay, so in this case, since we are talking about alpha over 2, we need to divide both sides by 2. Also by 2. Well, that's going to look a little bit weird, but that's going to be pi over 2 alpha over 2 3 pi over 4. Well, if you think of pi over 2, between pi over 2 and